best preheat source for optimum results. What would you consider to be the best preheat source for, to get the optimum results off the board? Let's go to Jochen on that one.
Yeah, well, to me, the preheat source, I understood it about how should the preheating be done. Like, I would say the preheater must be adapted to the size of the board, because the whole board size has to be preheated from the bottom side, so that the board can relax and can extend even in a balanced way, in a homogeneous way. So the heating must be homogeneous normally for the most of the boards, except some of the boards maybe have some special requirements depending on the board. And so sometimes it is good to have maybe a heating that can be configured in the power, so that maybe one area gets a little bit more heater power and the other area gets a little bit less heater power, depending a lot on the board. The main target should be, of course, to avoid the warpage of the board. So it's a matter of the size. So this also is the key for selecting basically the size of the Rework system. If you have only small boards, then maybe a small Rework system is enough. But if you have very large boards, then maybe you need XL Rework system, because only these systems, they have XL heaters. And mainly the people use infrared radiation from the bottom side, from the most of the systems. So some systems you have with hot air from the bottom side. But if you use infrared radiation, so then the medium wavelength infrared radiation would be maybe a little bit better than short waves, because the medium wavelength has a more balanced absorption than most of the materials.
Okay. Yeah. So Don, would you agree with that? Using infrared medium range would give you a fairly even delta T on the board, and then you use some other source to, around the areas of bigger components?
Yes, yeah, I think he did a great job summing it up. And, there's obviously arguments for what form of heating you use, but I think the most important thing, as he mentioned, is uniformly heating as much of the assembly as possible, ideally the entire assembly, because it's going to minimize the stress, both thermal and mechanical stress imparted on the board. There are cases we've seen with very, very large boards. We've seen boards that are over 1 meter long, and we've had very good results heating most of the board because it wasn't practical to heat the entire board. So if you have a preheater that's maybe 500 or 600 millimeters, and you heat the area surrounding Rework, then it's usually very, very effective. We've also worked with some customers that actually have been a little bit more aggressive, where they preheat the board offline, and they bring into the process tool a preheated board so that they're saving some throughput. So that's one additional consideration, because in the Rework process, preheating can be the majority of the time in the entire process.
Right. So they're preheating it just with a straight infrared heater offline? Is that what they're...
Yes, it could be a preheater offline, and we've manufactured a few. It could be just a basic oven, and they can pull them from the oven and put them on the Rework system, or bring them to the bench if it's a hand soldering operation. Okay. Of course, if they're moving a heated board, they've got to consider the potential human hazards, but when throughput is a key, that's one of the things they can do to speed things up.
Okay. Robert, you got anything to add to what's been said so far?
Yeah, I think that uniform heating is absolutely critical. It's a critical parameter. Big board, small board, flex board, doesn't matter. The fact is the PCB is going to be a thermal drain. So if it's not preheated correctly, then you have to be more aggressive to heat the component on top. In this case, we're talking about BGAs. If the board itself is properly preheated, then you don't have to be so aggressive on the BGA. I talked a moment ago about being able to recycle components to reball them later on, which we'll talk about again later. And so preheating the board correctly is a huge variable in a successful rework cycle. With regard to the source of how to preheat, Finetech Martin uses convection. I'm not personally a big fan of IR, though I know that IR does work. Living in Arizona, in Phoenix specifically, we're very familiar with what IR does to materials. And if there's a car outside that's black and a car outside that's white, you'll see a very different temperature in the summer because IR penetrates darker colors. It's attracted to darker colors. So if there's bottom side components that are BGAs or connectors, they're more susceptible to absorb that energy before the board. And so using convection in our opinion, is a better way to the absorption reflection ratio. And so for the source itself, convection is our preferred method to heat PCBs.
Right, that's really interesting. I didn't realize that infrared was attracted to light in that way. So I guess the color of the substrate would matter as well then.
It does.
Yeah. Bob, anything to add on that particular topic?
Well, I mean, first of all, the drying the boards. If you're drying the boards, then why not rework the boards after you've dried them? So you've already put the heat into the board. So I would be a great advocate of preheating the boards externally if required. And if they're very large boards, then getting the heat in slowly, as two of the panelists have said, I think is important. And it's the same for, it's the same for just standard desoldering. If we're not talking about the sexy stuff, the through hole. If you have problems desoldering a through hole component, put it in an oven, raise the whole core temperature up. It just makes life so much easier. On the preheat side, I would kind of always look at learning about the machine. So you've got a machine with far, near, middle, convection. So whatever the technology you use, understand the machine, understand the set points, and what is the difference between the set points and the actual on the board. So rather than saying use IR, don't use IR, use convection, don't use convection. If you understand the process more, and obviously you monitor it more closely, and to me personally, at new product introduction, MPI, it is the engineer's responsibility to define how we're going to rework and repair a product. It's his responsibility to check out the components, the equipment's available, etc. You can't legislate for every single component you're going to rework, but that engineering effort should be put in at the start.
Sure.
Not when you have a problem on the shop floor,
which is actually happening.
Yeah, it sounds sensible. I'll give you that much, but I'm wondering how often it's done as common practice.
Well, I kick engineers on a regular basis if I possibly can, in the politest, of course. Right.
Okay, moving on. How do you remove underfill on BTCs? We'll give that to Robert first of all.
Yeah, so the first thing to keep in mind is reworking underfill components. Keep in mind that the underfill is there's a purpose for it, right? The whole purpose of underfill is to not ever rework it. They want that component to stay on the board forever. And so it begs the question, why would somebody want to rework a board? And the normal answer is because it's a high value product and they want to be able to recycle it. So that being said, if you go to slot, well, let me say one more thing. Underfill rework is only possible if the material itself is reworkable. So it's quite important that if a company wants to try to rework an underfilled component, they need to get a hold of the underfill supplier and understand what that glass transition temperature is. If the material itself is not reworkable, it'll be nearly impossible to do underfill rework. In the instances that it is possible, if you go to slide number 3 on my that I sent over to you, can you show that, please? Okay, so basically what we've done is we've developed a knife tool that is basically built into one of our soldering nozzles, and the knife tool will allow you to get down into the fillet area between components. I believe the spec for neighboring components is 300 microns, and so what we can basically do is go in and we can shear off the fillet. And so if I go to that one slide, once we've removed the fillet around the component, we have a tool that will then physically go down and grab the component. And again, as we're heating up the component, we can reflow the solder, apply these clamping mechanisms that grab the component, and then lift it off of the PCB.
Right. Okay. Yeah, I mean, that's obviously becoming more and more important with miniaturization coming in, getting into these areas. Okay, Don, do you have anything to add to that about the issues around underfill? I mean, underfill is generally used as a support mechanism. for devices, but it's very difficult to rework, or it's painful to rework.
True, that's true. One of the additional problems that we'll face as we try to do that, and it affects corner glued components as well as underfilled components, is the added force required to separate the component from the board while you're doing the rework. A lot of times you can't rely on the simple vacuum tools most of us use doing the removal, that you need to apply some sort of force, either a lateral force or a twisting force. So that's one consideration. And of course, that's even more difficult in tight component spacing situations.
So
go ahead.
Are the adhesives used on corner bonds, are they stronger than is that what makes them so difficult to work with?
No, I don't think the corner bonding is necessarily more difficult than the underfill. In fact, maybe even a little easier. It's just a different approach. Typically, the corner bond would be used on very large BGAs, where the underfill material is wicked in using, basic, I can't even think of the term off the top of my head, but they fill the underfill and it wicks under by capillary action. When you have a very large BGA, say a 60 millimeter BGA, you won't have the capillary action and you have a higher standoff, so the underfill is less practical. And what they'll do then is use a epoxy corner bond or edge bond, sometimes around the whole perimeter of the BGA, for the same effect, providing some mechanical support for the device.
Right.
And in either case, what you have to do is use a tool similar to what Robert mentioned to remove the glue first. And then, as I was saying, apply some additional force during the removal, because it's not just the surface tension of the solder joints anymore. There's still some residual glue bonding strength.
Yeah. Jochen, anything to add to what Robert and Don have said so far on the subject of underfills?
Yes, this is all true. The underfills are really a very difficult thing if used at the components. It's true. It's mainly depends on the material of the underfill which is used. The manufacturer of the underfill knows best how to remove, or if it's removable at all. The IPC 7721 says basically, okay, check the data sheet of the manufacturer. So they don't give so much support in this case. Basically, you need some mechanical support to lift up the component. This is true. Just pulling at the component, no matter if you do it by a suction cap or by a clamping mechanism is already much better than just a suction cap, of course. Is sometimes anyway not enough, but mainly many people use something like a dental tool to just go to the edge and to lift it a little bit, so to crack the connection. Of course, you must be sure that you're over the melting point already, otherwise you have another problem, it's clear. And so in this case, if you can do that, then you can lift it off by a normal suction cap afterwards. But clamping mechanisms are one possibility. There are some systems on the market that use a twisting mechanism, but this is a little bit a problem if you have close adjacent components. So you may move the components then. So there are several possibilities, but one is clear. Underfill will always remain a very difficult thing. That's very clear. Beside all that stuff that you have different types and different ways to remove.
Yeah, I mean, Bob, if a device has got underfill underneath it, I guess the ability to damage the whole the board is greater.
Yeah, chemical things, for example, if you use some chemicals to resolve the underfill, it may also resolve things that shouldn't be resolved on the board. So sometimes this is a really critical thing.
Okay.
Also, especially some underfills, they harden really very much. So even if your component itself that you want to rework is not underfilled and a very close adjacent component has an underfill, then even this can be a problem, because then the solder may squeeze out because it really cracks the underfill and you have these little spots everywhere. And you can't avoid because you have a heat conduction inside the board of heavy mass boards that go below these underfilled components. You may cool them by adding additional thermal mass and so on. There are several possibilities how to support dealing around with these underfills.